Good afternoon, Algebra 2, time for lesson 20. Look at this background. I put this up here because it's Thursday. It is 67 and sunny out and it feels amazing. This is just a nice reminder of how miserable winter was as far as being cold and everything. So at least we finally got some nice weather. All right, speaking of nice weather, I'm going to put today's homework solutions outside on my driveway with chalk. That's going to be fun if it doesn't rain beforehand. All right, so we're going to finally talk about the B value. I've been telling you that we're going to mention this B value all along. So far, we've looked at the A value. We've figured out that that stretches our graph. We've looked at the C value to figure out that that shifts our graph up and down, moves that midline. Now the B value is going to do some weird stuff to these graphs. All right, it's going to be a lot more complicated than the other stuff. All right, so let's start off with defining what the B value is. The B value has a name. We call it the frequency of the graph. All right, what that means is how many cycles does the graph go through between 0 and 2 pi. All right, so that's the definition. So I'll give you a second to write that down. You can pause this actually if you need to. But that's what the B value is. It's called the frequency, and it tells us how many cycles does the graph go through between 0 and 2 pi. All right, what in the heck does that mean? All right, well, let me first talk about cycles. Let's take a look at sine x for a second. If you graph regular old sine x, and I'm only going to look from 0 to 2 pi right now because that's what frequency is talking about, you will see that sine will go up, come down, and finish back at 0 again. That's considered one cycle of sine right there. All right. So right now, this graph that I have drawn has a frequency of 1 because it's only getting through one cycle by the time it gets to 2 pi. So that's what one cycle of sine looks like. I could adjust that. Maybe my graph looks like this and goes up, down, down. That's 2 cycles of sine that it's going through between 0 and 2 pi. This graph would have a frequency of 2, which means there would be a little 2 in front of the x right here. All right, so that's what we're talking about when we're talking about cycles. Let me show you cosine. A cycle of cosine between 0 and 2 pi, traditionally, without doing anything to any of the values, is going to look like this. It's going to start up here at 1, go down, and finish back at 1. That is one cycle of cosine. So you need to be able to look at a sine graph and a cosine graph and recognize one cycle of it. All right. What if I wanted to throw a 2 out in front of that cosine? Well, now what would happen is I'd be seeing 2 cycles of cosine between 0 and 2 pi. So it would come down and finish up, come down and finish up. It would go through 2 complete cycles by the time it gets to 2 pi. So that is what the B value is. It's called the frequency. It tells us how many cycles the graph goes through. Now I'm going to show you how we use it to help us with our graphs. In order to successfully graph a sine or cosine curve where the B value has been adjusted, you need to know something called the period of the graph. So here's another new definition for us. The period is how long it takes the graph to get through one cycle. All right, so that is the definition of period. How long does it take the graph to get through one cycle? There's a formula that will help you find the period of the graph every single time, and that formula is going to be very useful when we try to graph these things. Let me give you that formula. Period is always going to be equal to 2 pi divided by your B value. So whatever your B value is, divided into 2 pi. We're not actually going to divide it in and get a decimal. We're going to leave it as a fraction, but that will get you the period of your graph. So I'm going to show you how that relates to all this. I'm going to do a graph with you right now where the b-value is adjusted, and I'm only going to graph these examples from 0 to 2 pi. I'm not going to do the negative side of them. You will see that in pre-calc, but I'm trying to keep it somewhat simplified here and just graph these from 0 to 2 pi. So we're only seeing this part of the graph from 0 to 2 pi, so we don't have to worry about the negatives because they get very cluttered very fast, and you'll see that here in my next example. So let me go ahead and get erased and do one for you here with a new b-value. All right, here's our first example. We're going to graph y equals sine 2x from 0 to 2 pi. All right. To do that, we need to know what this graph's period is first. All right, and you'll see why here in just a minute. So let's first find the period. Remember that period, we just learned, is 2 pi divided by the b-value. Well, in this case, our b-value is a 2. So it's going to be 2 pi divided by 2. The 2's will cancel out, and the answer is pi. So what does that tell us? It tells us that this graph will get through one complete cycle by the time it gets to pi on our graph. All right. So it wants us to graph this from 0 to 2 pi. So let me go ahead and get my values on my x-axis here, the ones we've been using all along. We got pi over 2, we got pi, we got 3 pi over 2, and 2 pi. But this graph isn't going to look traditionally like it has before because now we've changed this b-value. This graph is going to get through one complete cycle by the time it gets to pi. So we need to make sure that by the time we get to right here, this sine has gone through one full cycle. Now remember, a full cycle of sine looks like this. Starts here at 0, goes up, comes down, and finishes back at 0. That's one full cycle. We need to get one of those in by the time we get to here. So to make that happen, the graph's got to start here. It's going to have to finish here, this first cycle. Now look at the shape of it. Right here in the middle has got to be right here to make this work. So this graph is going to go, I should probably put my 1 and -1 in there because my amplitude is 1. This graph is going to go up to 1 and come down. There's the first half of it. It's going to come down to -1 and go back up. So I've got one cycle in now that I've gotten to pi. But I need to keep going because they did ask me to graph from 0 to 2 pi. So this whole thing's going to happen one more time. So it's going to come up to 1, come down to 3 pi, go down to -1, and finish back at 2 pi. Now I have completed my graph, and let's just discuss it real quick. Remember, this b-value has a name. It's called the frequency of the graph. Frequency, previous definition, how many cycles does the graph go through between 0 and 2 pi? This graph went through 2 cycles by the time it got to 2 pi, which is why the b-value is 2. I used that 2 to help me find the period, so I knew when my first cycle would end. So there's our first example. Let me just remind you real quick before I forget that we could also tie in all of the other stuff that we did in the previous stuff. I could change the amplitude to something and stretch this graph. I could put a negative out in front and reflect it over the x-axis. I could put a c value in here and shift this thing up and down. We can combine all of that together, all right? And I think I'm going to try to throw in a quick review for your quiz and do an example of one where I merge all of that into one thing for you, all right, just to show you what that would look like. All right, I'm going to erase and do my last example. All right, so for our last example, we're going to graph y equals cosine 4x from 0 to 2 pi. All right, so like I said before, we're always going to do these from 0 to 2 pi, so we don't have to worry about the negative part of it. All right, so the first thing we need to do is tell what our period is. Remember, period is 2 pi over b. So in this problem, it's going to be 2 pi over 4. Now, I'm not going to actually divide that out on the calculator and get an answer. I'm going to leave that as 2 pi over 4, but I'm going to actually reduce it because 2 and 4 will reduce. So this reduces to pi over 2. So that tells me that this graph is going to finish its first cycle by the time it gets to pi over 2 this time. All right, so let's look at what that's going to look like here. Let's get our graph sketched in here. Let's get our x-axis labeled. We got pi over 2, we got pi, 3 pi over 2, and 2 pi. You're going to want these spaced out a little more than usual because there's a lot going on here. All right, we have an amplitude of 1 because there's no A value. Well, there's an A value, it's 1. So it's going to go up to 1 and down to -1. So what does one cycle of cosine look like? One full cycle of cosine starts here, comes down, and finishes here. So that's what one cycle looks like. I need to complete one cycle by the time I get to pi over 2. So by the time I get to here, I already need to see one full cycle of cosine. So that means it's going to be very skinny now. It's going to come down and finish up right there. So this graph has been squished together, all right? Okay, so if it finished one cycle by the time it got to pi over 2, how many cycles is it going to finish by the time it gets to pi? It's just basic math here, right? If it gets through one cycle here, then it's going to go through another one here, another one here, and another one here for a grand total of 4 cycles. Why 4? Because the B value is 4. That's called the frequency, all right? So it's all connected together. So let's go ahead and finish this graph off. We're going to see another cycle in between here, another cycle in between here, and one last one in between here. So we have a grand total of 1, 2, 3, 4 cycles because the B value, which is called the frequency, was 4. All right? Again, the period just let us know when that first cycle was going to occur. It's going to occur at pi over 2. That's what that was for. And then we finished up from there. So you can see why we don't have you usually graph the negative side, because this graph would have to be really wide to get all the negatives in over here. So we usually just do 0 to 2 pi, keep it quite simple for you. All right, again, like I said, I could throw a number in front and stretch this thing. I could throw a number on the end here and shift it as well. All right, we'll get into that. Like I said, I'll do a quick mini lesson on Monday to get you ready for your quiz and should just show you a couple examples of tying it all together. All right. Okay, so I'll put the homework up. I'm just going to have you graph, I think 3 of these, 2 or 3. I can't remember what I have on there for homework. I'm going to put the solutions out on my driveway in chalk, hopefully before it starts raining. I'm looking out the window here. Still sunny out. That's good. That's better than this nonsense. Okay.